my dear students, how are you all doing? I believe and I expect that you all must be doing great. This is me, Seema Banjare, your mentor, your guide. And do you remember that in the very first video, that is part 1 of polynomials, I told you that I'll be dividing this chapter into 3 parts, right? But to my surprise, I ended up dividing this chapter into 5 parts. So welcome to part 4 of polynomials, and let me tell you what all we are going to discuss in today's class. So we'll be starting with the applications of factor theorem, right? Then we will move on to discuss middle term split, right? And at last we'll be discussing how we can factorize a cubic polynomial using these two means factor theorem and middle term split. So this is what we are going to discuss today, we are going to study today. So shall we start? Okay, so let's quickly dive into the session straight away. So the first concept that we are going to discuss today is applications of factor theorem. But before we actually start with the applications, let's quickly revise factor theorem in a go. Okay, so what factor theorem says? It says that factor theorem. So factor theorem says that if Px is a polynomial of degree 1 or greater than 1, okay, if it is a polynomial of degree 1 or greater than 1, if it is a polynomial and it is divided by a linear polynomial x minus a, okay, then if p of a is 0, if it is 0, then x minus a will be its factor. Then x minus a will be its factor. Okay, right? If px is a polynomial divided by x minus a, okay, the first case, if p of a is 0, then x minus a will be its factor. And the second case says if x minus a is a factor, okay, then p of a will be 0. Right, vice versa. Basically these conditions are vice versa of each other. Means p of a will be 0, then x minus a is a factor. If x minus a is a factor, then p of a will be 0. Clear? So this is what factor theorem says. We have discussed a lot about factor theorem in part 3. So today we will be focusing on its applications. Okay, so let's take up the first application of factor theorem with the help of an example. Okay, so you see a question mentioned on your screen. So this is the first application of factor theorem. Let's solve this question, and while solving this we'll get to know that how we can apply factor theorem to such questions. Okay, so what the question asks you to find out, it asks you to examine whether x plus 2 is a factor of this polynomial. Okay, you have to find out whether x plus 2 is a factor of this or not. Okay, so what factor theorem says, if it will be a factor, if let's say x minus a will be a factor only if p of a is 0. Okay, x minus a will be a factor if p of a is 0. Okay, so we have to check here that whether x plus 2 is a factor of this or not. Okay, x plus 2 will be a factor only if p of minus 2, okay, is x plus 2 means p of minus 2 will be 0. Okay, we have to find out p of minus 2. If p of minus 2 comes out to be 0, then we'll say yes, x plus 2 is a factor. If it doesn't come out to be a 0, we'll say it is not a factor, right? So what we need to do, we need to find out p of minus 2. Why minus 2? Because it's x plus 2. So that's why we are going to find out p of minus 2. Had it been x minus 2, we would have, in that case, we would have found p of 2. Clear? So here we have to find out p of minus 2. So p of minus 2 means wherever variable, like in wherever there is x in the polynomial, we need to replace it with minus 2. So minus 2 cube, right, x cube plus 3 minus 2 square plus 5x, right? So x means minus 2 and plus 6. So what we are doing, we are replacing x with minus 2 in the whole equation. Now let's solve it. Minus 2 cube minus 8 plus 3 minus, now just don't make mistakes with this plus and minus, okay, because I have seen students start right, okay, they try to solve it in a nice way, but just because of these silly mistakes, plus and minus mistakes, they ended up doing the question wrong. Okay, So this is minus 8 plus 3 into minus 4 is minus 2 square is 4. 4 into 3 is 12. 5 minus 2 minus 10 plus 6. Now plus, okay, we'll just add up similar signs. So plus 12 plus 6 will be plus 18. Okay, and minus 8 and minus 10 will be minus 18. So minus 18 plus 18 cancels out and the answer is 0. So P of minus 2 is 0. P of minus 2 is 0 means x plus 2 is a factor of this. Okay. So yes, it is a factor. X plus 2 is a factor of the, this mentioned polynomial. Okay, so this is the first application of factor theorem. But in such cases like where we have to find out whether it's a factor or not, we use factor theorem. Okay, so this is the first question. Now let's move to our second question. So the next question for you is this. Okay, here again you have to examine whether this is a factor of this. The same kind of question, okay, like the previous one, but the challenge is, you see, you have to find out whether 2x plus 1 is a factor of this polynomial or not. Okay, 2x plus 1 means how we can find out whether it's a factor or not. Simply we'll find out P of A. Okay, but we don't know what to replace A with. We don't know. Okay, because it is 2x plus 1. It's not like the previous case. There it was x plus 2, but here it is 2x plus 1. Now we are confused what we should replace A with. Okay, so what to do in such situations? We'll simply 2x plus 1 will simply equate 2x plus 1 with 0, and from here we can find out the value of x. So x will be 1 will go to the right hand side, it will be minus 1. Okay, 2x is equal to minus 1. So x is equal to minus 1. Whatever is in multiplication here with x, it will go down. Okay, so it's minus 1 upon 2. Clear? Now x is minus 1 upon 2. It means we need to replace a with minus 1 upon 2. So what we will do next, we'll find out p of minus 1 upon 2. So in place of a, what we'll place minus 1 upon 2. So we have to find out p of minus 1 upon 2. P of minus 1 upon 2 means wherever there is a variable in the polynomial, so wherever there is x in the polynomial, we'll replace that variable, that x, with minus 1 upon 2. Okay, so let's do it. So it's 4, okay, P of minus 1 upon 2 means 4 minus half square, minus 1 upon 2 square, plus 6x means 6x means minus 1 upon 2, and again plus 1. So what we are doing, we are simply replacing x with minus 1 upon 2, and then we'll solve it. So 4 minus 1 upon 2 square means 1 upon 4. 1 upon 4 plus, now this is only 1 upon 2, so the sign will be minus here, plus minus minus. So 2 cancels 6, it will be 3. So minus 3 and then plus 1. So 4 cancels 4, 1. So 1 minus 3 plus 1. Now plus plus. So plus 1, 2. And 2 minus 3 will be minus 1. So P of minus 1 upon 2 is minus 1. So what do we conclude from here? P of A is not equal to 0. Okay. So P of minus half is not equal to 0. And if it is not equal to 0, it means 2x plus 1 is not a factor of this polynomial. Okay, simple, right? So let's move on to the next question. Okay, so the next question for you is this. Here you have to find out to factorize y square minus 5y plus 6 by factor theorem. Yes, you can use factor theorem to factorize a polynomial. Okay, how we can do so? Let's see it. Okay, so we have to factorize it by using factor theorem. So factorize means we have to find the factors. Okay, as you can see, this is a degree 2 polynomial, means it is a quadratic equation. So it means it will have maximum 2 factors. Okay, so let's find out those 2 factors using factor theorem. So what factor theorem, let's recall factor theorem once again. What factor theorem says, okay, px is divided by x minus a if p of a is 0. Okay, if p of a is 0, you replace x with any value and that comes out to be 0. If that is 0, then x minus a will be a factor. Clear? So this is what we have to make use of it in this question. We will try replacing, we will we will use hit and trial method here. We will replace y with different values, and if that comes out to be 0, let's say I replaced y with -2 and the whole expression became 0, it means x plus 2 is a factor. If I replace y with 2 and the whole expression reduces to 0, then I'll say that x minus 2 is a factor. Simple. Okay, so we are just using hit and trial method here. Okay, and then we'll find out the factors, right? So how we do this? Okay, so first of all, just see this expression and the last constant term. So the constant term is 6. Now what all factors 6 can have? 6 can have +1 -1 factor, right? 6 can have plus -2, both +2 and -2 as well. So 6 can have +3 -3 as its factors, and 6 can also have +6 as its factors. So these are the possible factors of this number, this constant term 6. So these are the possible factors, right? So we'll start with +1 -1. Now we have to find out that value of a, okay, which on replacing here will make the expression 0. So we have to find out a, okay, we have to find out that value at which this expression reduces to 0. So we have to find out that value. So let's try finding it out by hit and trial method. Okay, so let's replace this with 1. Okay, so this expression is this. I'm replacing y with 1. Let's try it out. So if I replace y with 1, what I'll get? -5 into 1 plus 6. Okay, so 1 minus 5, it will be 5, plus 6, it will be 7 minus 5, that is 2. Okay, not equal to 0. So this is of no use to me. Now what I'll do, I'll again replace with -1. So -1 means wherever there is y, I'll replace y with -1. So this is y square, so it means -1 square minus 5 into -1 plus 6. Now let's see what it is. -1 means +1, and this is +5 plus 6. So again it will be 12. Now again this hasn't reduced to 0. It means again this value is also of no use to me. It cannot be a factor. Now I'll try with 2 now, +2. So I'll replace y with 2. So what I get? 2 square minus 5 into 2 plus 6. Okay, you know what I'm doing? I'm replacing y with 2. Okay, what we need that value of y at which the expression becomes 0. Okay, so let's see. This is 4 minus 10 plus 6. So 4, 6, 10 and minus 10. So it will be 0. Okay, so now this is of my use. Okay, so at 2 the expression has reduced to 0. It means p of, okay, x y minus 2. At 2 this expression has reduced to 0. It means y minus 2 is its factor. Okay, so we have got one factor here, right? So we need to find out other factor as well. So p of y minus 2 is a factor. Now let's find out other factor as well. So again you just repeat this method, hit and trial. Again you can see that p of 3, at p of 3. Okay, so we got one factor, that is y minus 2 is its one factor. Now I'm just rubbing it off so that we can find out other factor as well. So we got one factor. Now we'll find out the other factor again by hit and trial method. So p of 3, will try to find it out, p of 3. So wherever there is y, we'll replace it with 3. So 3 square minus 5 into 3 plus 6. So it's 9. 9 plus 6 will be 15, and 3 into 5, 15. So plus 15 minus 15 will make it 0. So again this is also of my use, because p of 3 has become 0. Okay, it means y minus 3, p of 3, right? So y minus 3 is a factor. So I got my two factors, right? So what are the factors? Y minus 2 and y minus 3. So these are the two factors of this expression. Okay, shall we, should we find out other factor as well? Okay, no, because it cannot have more than 2 factors, because it is a degree 2 equation. It is a degree 2 polynomial, so it can have maximum of 2 factors, and we have got both these factors. One is y minus 2 and the second one is y minus 3. So this is how we can use factor theorem to find out the factors of a polynomial. Okay, right? So let's now move to midterm split. Okay, middle term split. Middle term split. Okay, let's now understand this concept with the help of an example, right? So I'm taking the same example which like that same question which we have just solved by factor theorem. So we are just taking the same question, y square minus 5y plus 6. So we have to factorize it. Actually, middle term split, we use this this process, or you can say this concept, to factorize a quadratic equation of this form. Quadratic equation means a degree 2 equation of this form. This form means first term should be a square term, second is a single part term, and then a constant term. So if a quadratic equation is in such form, then we use middle term split to factorize it. Okay, right? So let's factorize it using this method. As the name says, okay, what the name of the concept says, middle term split. It means you need to split the middle term. You need to split this term. Okay, split into what? Split into 2 such numbers which on multiplication gives you 6 and on addition or subtraction gives you this number, right? So what we should do now, what we are going to do now, we are going to find out 2 such numbers which on multiplication gives us this constant number, this number, right, 6, and which on addition or subtraction gives us this number, right, 5. Okay, so how we can find out those 2 numbers? Here in this case it is easy, right? But still I'm telling you how, if it is a, you know, a larger number, then in that case how we can find it out. We'll just find out prime factors of this constant term, right? So here the constant term is 6. So I am supposed to find out its factors, prime factors. So 2, 3, 6 times, right? And 3, 1. Okay, so I have got 2 factors, 2 and 3 now. So 2 and 3. So these are the 2 numbers, okay? Because these numbers 2 and 3 on multiplication gives you 6, and on addition 2 plus 3 is 5. So we got our numbers 2 and 3, right? So what my next step would be? To split this number, this middle term, minus 5y, I need to split it. Okay, so while splitting, make sure that you don't distort the whole equation, right? What I mean by that, so this is minus 5y. I need to break it into 2 and 3, 2y and 3y. So minus sign, it means minus 2y minus 3y plus 6. So this is how I split the middle term into 2y and 3y. Okay, this is what I did. Now just ensure that you haven't distorted the equation. Means minus 2y minus 3y, minus 2y minus 3y gives you minus 5y. It's correct. Okay, if you use a plus sign here, in that case it would be wrong. Why? Because minus 2y plus 3y will make it y, okay, not 5y. So that would be wrong. So always be careful with the signs. So it should be minus 2y and minus 3y, because minus 2y and 3y, minus 3y gives you minus 5y. Okay, so that is correct, right? Now we have splitted the middle term. What we are going to do now? So just make pairs. So I'm just using these 2. So the first pair and second pair, right? Now these 2 numbers, these 2 terms, you can see anything is common between these 2. Y is common, so I'll take the common term outside, y minus 2 inside, because y common means just left, y will be left here, and then if you remove y from here, you are left with 2 only, right? Now this minus sign, 3y and 6, what is common between these 2 terms? 3 is common, so I'll take 3 outside, and inside I'm left with y. Okay, so I have taken minus outside. So minus common. If you, whenever you know, there's a minus sign before a bracket, you insert a bracket and there's a minus sign outside the bracket, you make sure that you're changing sign of, you know, whatever is left inside the bracket. So it's plus 6, it will become minus, okay, plus 6, 3 is out, means 2. So minus 2. Okay, so we have taken 3 outside. Why I changed the plus sign into a minus sign? Because I have a minus sign outside the bracket. So make sure that if you are inserting a bracket, then outside the bracket if there is a minus sign, so make sure to change that the signs of whatever numbers are inside the bracket. Clear? So that's why there is this minus sign. Okay, now you see that these two terms, right? In both these terms we have y minus 2 common. So what we will do, we'll take it out outside. Minus y minus 2, y minus 2, we'll take it common, and now we are here. Okay, y minus 2 we have taken out, so we are just left with y here, and here we have taken out y minus 2 outside, so we are left with 3. So you see, I got my two factors, y minus 2 and y minus 3, and this is what we got from the factor theorem also, y minus 2, y minus 3. So isn't it simple, right? What do you think? Is this simple? A factor theorem was simple. We did the same thing. We tried to find out the factors of this expression, right? This polynomial. We did it with factor theorem also, and now we found the factors using middle term split. You see that middle term split method is far better than, you know, factorizing a quadratic polynomial using a factor theorem. So which theorem you are going to use? Either a factor theorem or middle term split. What you will use? Definitely you'll go for middle term split, because this is much easier and much quicker, right? So whenever you have to solve a quadratic equation of this form, you will not use factor theorem. Okay, we are not going to use factor theorem to find out the factors of such equations. In such polynomials we'll just use middle term split and we'll find out factors. Okay, right? So let's solve one more question using middle term split so that it becomes more clear to you all. Okay, so the next question you have is this. You have to factorize this. You can see that this is also quadratic equation. Okay, and it's a quadratic equation and it is in the standard form, right? Square term, then the single variable, and then constant term. So we can solve this, you factorize this using middle term split, right? So how we are going to do this? So this is 12x square minus 7x plus 1. We need to factorize it, okay? But here you see there is this constant term and there is this 12 also. Before x square we have 12. So we need to find out two numbers. Always just multiply 1 and 12, whatever coefficient you have here in front of x square, you need to take this term as well. So we want two such numbers which on multiplication gives us, just multiply 12 and 1. 12 and 1 is 12, right? And this number is 7. Okay, so we want two numbers which on multiplication gives you 12 and on addition or subtraction gives you 7. We want two such numbers. Okay, so how we can find out those two numbers? Let's find out the prime factors of 12. Now 2, 6, 12, 2, 3, okay, and 3, 1, right? So these are our prime factors. Okay, so I got my number. On addition it should give 7. So 2, 2, 4 and 3. So what are the two numbers? 4 and 3, right? So 4 and 3 are the two numbers, and we have to split 7 into those two numbers, right? 4 plus 3 is 7, right? So let's do it. 12x square minus 7x. So what are my two numbers? 3 and 4. So minus 3x minus 4x. Be careful with the sign again. I cannot use a plus here, because once I use plus here, it will become minus 3x plus 4x what? X, right? So that would totally distort the equation. It should be minus here. Minus 4x, minus 3x, minus 4x. Now what is the next step? I need to, make groups of first two terms and the last two terms. And if in both these groups we need to find out what is common. In 12x square minus 3x, what is common here? 3x is common. So whatever is common, take it outside. 3x is common. 12x square, 3 comes out, 4, x comes out, only x is left, and then 1 is left, right? Now again, there is this minus sign. So whenever, and in 4x and 1 there is nothing common, so we'll take 1 common. If nothing is common, means we are taking 1 common. Okay, so we are inserting a bracket. We have taken minus outside, inserting a bracket, and now what I'll do? 4x and plus sign. So if a minus sign is outside a bracket, then we need to change the sign of whatever is left inside. So it will become minus 1. Are you getting the point? Okay, it's minus sign. We change this plus sign into minus sign because we had minus sign outside the bracket. So that's why we changed this plus sign into a minus sign, right? Now the next step. So you can see in both these terms 4x minus 1 is common. What we will do? We'll take it outside, right? Take it common. 4x minus 1 outside, and we are left with, from here only 3x is left, minus 1. Minus 1 is left. Now my two factors are 4x minus 1 and 3x minus 1 are the two factors. Isn't it simple? Yeah. So middle term split is an easier way of solving quadratic equations which are in standard form. So for such equations we are not going to use factor theorem, right? So you'll be using middle term split for all such equations, right? Okay, let's move ahead in this session. Let's start our last concept for the day, and you remember that I told you that we'll be discussing how we can factorize a cubic polynomial using making use of both these theorems, like factor theorem and middle term split. So we'll see how we can factorize it using both these, because we need to use both of these concepts to solve this. We need to factorize this. Okay, so let's see how we do it, right? So first of all, the first step is to, as you can see that it is a 3-degree equation, 3-degree polynomial. It is not a equation. You can see this is not an equation because there is no equal to sign here. So it is a polynomial, cubic polynomial, right? So it is a degree 3 polynomial, and at most it can have 3 factors. So a degree 2 polynomial can have at most maximum 2 factors. Degree 3, it can have maximum of 3 factors, right? So it will be having 3 factors, and we need to find out those 3 factors, right? How we are going to do so? Let's see. So the first factor, right, one of the factor we will find out using factor theorem. Again, so we have to find out one factor using factor theorem. Just see the constant terms, last constant term. So this is 2. So we need to find out the factors of the possible factors of 2. So 2 can have what possible factors 2 can have? Plus 1 minus 1, right? And plus 2 minus 2. So these are the possible factors that 2 can have. Okay. So what we have to do now? We have to find out one factor. So in order to find out one factor by using factor theorem, we'll just find out that number at which this polynomial reduces to 0. So what I'll do, so these are the possible factors. I'll try keeping them one by one, and at which the polynomial becomes 0, that will be my factor, right? So let's find out P of 1. Okay, so P of 1 means I have to replace x with 1. So 1 cube minus 2 1 square minus 1 plus 2. So how much it is? 1 square minus 2 minus 1 plus 2. So this is plus 3 minus 3 will become 0. Okay, so P of 1 has become 0. It means P of 1 is 0, means x minus 1 will be my factor. P of 1 is 0. It means x minus 1 will be the factor of this polynomial. So x minus 1 is our first factor, is a factor. Okay, so we got our first factor. What is the first factor? X minus 1. We need to find out the rest of the factors of this polynomial. Okay, so rest of the factors means 2 factors are still left. So we need to find out them. How we are going to do it? We'll divide this whole polynomial with our first factor. We divide this polynomial with this x minus 1. Okay, let's do it. Okay, so we have to divide this with this. Now I'm just rubbing it off so that we can divide it. So x minus 1 is our factor. So we are going to divide this polynomial. You know how we can divide, right? We have already done division of polynomial in the first part of this chapter. You can second part of this chapter. So in order to see how we divide, you can just refer to that part. Okay, so we need to divide this with one factor that we have just got. So x minus 1 is our factor. Now let's divide it. Okay, so x square. So first term, so x square into x is x cube. Now x square into 1 will be minus x square, right? Now we need to change the sign. It will be minus, it will be plus, and cancels out. Minus 2x square plus x square will make it minus x square. Whatever is left, you need to bring it down. Minus x plus 2. Okay, now again repeat the process. First term, x square divided by x makes it minus x. Minus x into x will be minus x square minus x into minus 1 plus x. Always take care of, be careful with the signs, right? Otherwise you will end up getting a wrong answer, which you will not want. So this is plus, now minus cancels out, minus x minus 2x and plus 2, right? Now the first term, right? Minus 2x divided by x will be 2. Minus 2 into x, minus 2x. Now minus 2 multiplied by minus 1 gives you plus 2, okay? Alright, now again we'll change the sign. Minus will become plus and plus will become minus, and then everything cancels out and the remainder is 0, okay? So this is our first factor, and whatever quotient we have obtained here, this quotient, can you see this quotient what it is? It is a quadratic equation, okay? Now we will factorize this quadratic equation using middle term split, okay? So let's do it. I'm just rubbing it off so that we can have some space here. So I got this quadratic equation. I have one of my factor. I need two other factors, and how I'll get my two factors? I'll factorize this quotient using middle term split, right? I'm just rubbing it off as well, x minus 1. Now this is the expression quotient that I need to factorize using middle term split. So x square minus x minus 2. I need two numbers, right? Now I need two numbers which on multiplication, see, x square doesn't have anything in the coefficient, right? So it means I need two numbers which on multiplication gives me 2. And what is the coefficient of x? Nothing. It means 1. So 1. I need two numbers which on multiplication gives me 2, and addition or subtraction 1, right? So what can be such numbers? Multiplication 2 and plus minus will be 1. So 2 in 1, right? 2 in 1. 2 in 1 on multiplication gives 2, and 2 minus 1 gives me 1, right? So let's proceed with it. So x square and minus 2x, minus x. So minus 2x plus x minus 2. Can you see here? This is how I split it. Minus 2x plus x. Minus 2x plus x will give me minus x, right? So now again we'll make groups. X outside, x inside. So whatever is common, I'm taking it outside. So I'm left with x and minus 2, right? Again here nothing is common between these two terms. So what is common? 1. So we are left with x minus 2. Now the next step, the last step, I need to take out whatever is common. So x minus 2 is common in both these terms. So x minus 2 comes out. What is left? X here and 1 here, right? So these are the two other factors. So what are the total factors? So we got 3 factors, right? So one factor that we got by using factor theorem was x minus 1. Now these two factors, x minus 2 into x plus 1. So these are the 3 factors of this polynomial. Clear? Okay. So this is how we can use middle term split and factor theorem to find out the factors of such cubic expressions, right? There are, like a lot of questions in your book. You practice them. The procedure will be same, that one factor you need to find out using factor theorem, and then you need to factorize then you need to divide the polynomial with the factor that you have got. Once you divide it, whatever quotient you obtain, that would be a quadratic polynomial. So you need to factorize that quotient using middle term split, and then you will get 2 other factors. So in all you will get 3 factors, right? So this is how you can solve such questions, okay? So solve more questions from your book, right? And with this we have come to the end of the video. I want you all to solve and practice more and more questions. Give a lot of love to this video. Like, share and subscribe to the channel, okay? We'll see you in the next video. Till then, you take care. Bye bye.